Let's find federal debt per capita with two different approaches because sometimes one way works better than the other. So the problem we're going to do here is the federal debt in 2000 was $5,674,178,000,000, and the population was 281 million. Finding federal debt per capita. Now, the first way is I see this first number, right? Our federal debt is given in standard form. So if I say, okay, I'm going to write 281 million in standard form. Well, remember that million means 6, so like times 10 to the 6th. So if I take 281 and add 6 zeros, now I'm in standard form. Now you could type that into your calculator if you'd like. You also can say, well, because these are zeros, they're going to cancel out, and I'm left with 5,674,178 divided by 281, and we're going to get a federal debt per capita of $20,192.80. Great, that's method one. Remember, with method one, you don't necessarily have to cancel out the zeros. You could just type those big numbers into your calculator and hit enter. You should get the same answer. Now, if you say, well, I see scientific notation, right? Super big numbers mean scientific notation. So we could say, well, oh, okay, back up. Right now, the decimal point is at the end. So if I go 3, 6, 9, 12, I'm moving it 12 places. So I'm going to have 5.674178 times 10 to the 12th. Remember, when you're changing things to scientific notation, you need all of the non-zero numbers. So now, when I go to take 281 million, again, remember that million means 10 to the 6th. But I also need to move my decimal 2 more places. So that's going to give me 2.81 times, I'm going to have 6 because of the million, plus 2, so 10 to the 8th. So now when I divide my beginning numbers here, I get 2.019280427 times 10 to the 12 minus 8 is 4. Then to change that back to standard form, I say, okay, my exponent is 4. So I go 1, 2, 3, 4. So I have 20,192.80 cents. So you'll notice you get the same answer no matter which approach. One other thing that maybe some people say is, well, I know that million means times 10 to the 6th. So I could do 281 times 10 to the 6th. Well, if I want the top one to also be 10 to the 6th, this gets into a little bit more like really understanding and thinking through. But if this was my federal debt right here at the bottom in gray, and I want it to be times 10 to the 6th, that means I want to move my decimal 6 places. So 1, 2, 3, 4, 5, 6. So I would have 5,674,178 times 10 to the 6th, because this would give me times 10 to the 6th. So if you do that, right, anything over itself is just 1. They cancel out. And we're back to that beginning piece in like part 1, which also ends up simplifying to 20,192.80 cents. So you have a couple of different approaches of how you can do these when you're dealing with these super large numbers.